Hello again. Our last topic in 1.3, which is our review of lines, is two more concepts that are related about parallel and perpendicular lines. So we have to remember what parallel and perpendicular means. So here we go, parallel lines, right? They go on forever and they never intersect. They never touch each other. So they never, ever, ever, ever intersect. So, here's just a little picture of what that means. I mean, they could be going up from left to right or down from left to right, positive slope or negative slope, but they will always be going up or down at the same rate. So in order for this to happen, these lines will always need to have the same slope. So let's see, they have equal slope or the same slope. So as a little example, if we were looking at the line y equals 1/2 x plus 3, then any line with a 1/2 in front of the x, right, because this is the slope, is going to be parallel to this line. The plus 3 just moves, the line up and down, so we will just have it, maybe 1/2 x plus 10. Right, this would be a line that is parallel to the other line. So they have the same slope here, and so that means that they are parallel. So, we want to be able to see if lines are parallel by looking at their graph, but also by looking at their algebraic formula. So same number in front of the x means you have the same slope if it's written in y equals mx plus b form. Okay, perpendicular lines, these do intersect. In fact, every set of two lines will intersect unless they're parallel. Perpendicular lines intersect in a certain way, in a special way, and they intersect perpendicularly or at a right angle. Okay, in other words, at 90 degrees. Okay, so what the picture of that looks like, right? So here's a line. And so a line that is perpendicular to this line, there will be more than one, because we could, well, here's one here. And they're perpendicular at this point. But we could have another one that's over here, right? And that's perpendicular to the same line we were given. Like one over here would also be perpendicular. But the thing is that they have to intersect at a right angle here. In terms of their slopes, these obviously don't have the same slope. One will be positive and one will be negative, so they have opposite signs, but also the rise and the run are swapped. Okay, so in other words, when you look at the slope as a fraction, you flip the top and the bottom, or the numerator and the denominator, and that is called taking the reciprocal. Okay, so they have negative or opposite reciprocal slopes. So we negate the slope and then flip the numerator and the denominator. So for example, just stick with our first line we had before, y equals 1/2 x plus 3. So here we have a slope of 1/2. So to find the reciprocal, we're going to flip the numerator and the denominator. That will put us at 2/1. And then we also have to negate it, make it negative. Okay, so a line that is perpendicular to this line will have slope negative 2/1, but we don't need to write the over 1. And then, I don't know, it could have any y-intercept. It doesn't matter. Again, that would just mean that we have a different line kind of moved up or down, but it has to have the same slope. So I don't know, -5. Okay, so here these slopes are negative reciprocals. So negative reciprocal slopes. So these guys are perpendicular. All right, so let's look at one example with finding some parallel and perpendicular lines. Okay, we're going to write an equation of the line passing through the point 2, 1. That is, in part A, parallel to this given line, 4x minus 2y equals 3. and then also a different line that will be perpendicular to this given line, 4x minus 2y equals 3. I know I'm a huge fan of connecting algebra and geometry, like graphing, and I think it's helpful to see something in many different ways. So I would just, we're not asked to graph this line, but why not just to see what's going on, but in a geometric sense. So 4x minus 2y equals 3. In order to plot that line or to graph that line, an easy way would be to find, well, two ways I could say. Either find the intercepts and connect them, the xy intercepts, or put this into y equals mx plus b form, and then plot it that way. Maybe a good review would be to plot this by finding the intercepts. So again, this is a little extra, but I think it's a good review. So let's find the x-intercept. Right, this is when we plug a 0 in for y. So we have 4x minus 2y times 0 equals 3. So we have 4x equals 3, and so we have x equals 3/4. Okay, so let's see, 1, 2, 3, let's go out 1, 2, 3. 3/4 is, like about here, 3/4 of the way to 1, and so here's our x-intercept. Now our y-intercept, right, remember that that's on the y-axis, and every point on the y-axis has an x-coordinate of 0. So we're going to plug a 0 in for x. Okay, so negative 2y equals 3, so y equals negative 3/2. So that's negative 1.5. Oops, so I got to extend my axes here. Okay, so on the y-axis, we've got a y-intercept of negative 1/2, so that's about here. Sorry, negative 1.5. Okay, so if we connect these together, oops, that's not great. Let's see, something like this would be the line that we are given. Okay, so this is the 4x minus 2y equals 3. Now we are looking for another line that passes through 2, 1. So that point, 2, 1, that's right here. Obviously, the line that we are given does not go through this point. What we want to do in part A is find the line that's parallel to this one. And there's a bunch of lines that are parallel to this one, but we want the one that has the right slope and goes through that point. Okay, so it looks like we're going to need to find the slope of this line in order to figure out what the slope of the line is that we're looking for. So in order to do that most easily, we want to put this into y equals mx plus b form. I know that the slope m is the number that is in front of the x, but that's only if it's written in the particular form, the slope-intercept form. This is in what's called standard form. So we can write that in slope-intercept form. Let's see, get slope-intercept form. And the way that that's done is just by solving for y. Okay, so we're going to have 4x minus 2y equals 3. And we'll just rearrange this and solve for y. So I'm going to subtract 4x from both sides. So that'll give us negative 2y equals negative 4x plus 3. And I'm just putting this negative 4x in the front because that's normally how we have the lines written. Okay, then we need to divide by negative 2 to get y alone. And when you're doing this on the right side, make sure that you divide everything by negative 2. So the negative 4 gets divided by 2, and so does the 3. So that'll put us into y equals negative 4 over negative 2 is positive 2. And then we have 2x minus 3/2. Okay, so this means that the slope is 2. Since we're looking for a parallel line, that means that the line that we're looking for is going to be equal to 2. All right, so for our parallel line, so now we're working towards now building our line that is parallel. Okay, that's going to look like then y equals 2x. Now we have to figure out what b is, right? We don't have b, we just have the slope. But we do know that this line that we're looking for goes through the point 2, 1. Okay, so we're going to find b by plugging in the point. Plug in 2, 1. Make sure that things go in the right spot. So x is 2 and y is 1. Okay, so we got 1 equals 2 times 2 plus b. 1 equals 4 plus b. And if we subtract 4 from both sides, we'll solve for b. So that gives us b equals -3. Okay, so the parallel line that we were searching for is going to look like, if we had a formula for it, y equals 2x minus 3. So this is the one that is parallel to the given one. So if we just sketch that line, so it's going to have a y-intercept of -3, a slope of 2. So let's go over 1 up 2. So that's here, over 1 up 2. Great, that hits the point that we're looking for, right? Over 1 up 2. And so we'll just connect those lines together. And so here's the parallel one. All right, let's find the one that is perpendicular to the black line, the given one, that also goes through the point that we had. Okay, so we can see, from the graph, from our picture, that if it goes through this point and is perpendicular to the black line, then it's got to look something like this, right? So it should have negative slope, and it should go through that point. So let's go ahead and find its formula. Now we already did some work for this in part A. We know that the slope of the line that we're given is 2. And so since we have a line that's going to be perpendicular, we will negate this slope and then find the reciprocal. Okay, so perpendicular, this would mean that the slope is going to be negative, and then 2 over 1's reciprocal is 1/2. Okay, so what we have now is y equals -1/2 x plus b, and we have to find what b is. So again, let's find b. We're just going to use the same point, plug in 2, 1. Right, we've got 1 equals -1/2 x, which is 2, plus b. -1/2 times 2 is -1. We'll add the 1 to both sides, and that gives us a b value of 2. And so our perpendicular line will look like y equals -1/2 x, and then plus 2. Okay, so let's plot that and see if it makes sense. I hope it does. I hope it works out. So we've got a y-intercept of 2 here. Our slope is -1/2. So we can find another point on here by going, so it's rise over run. So we'll go down 1 and over 2. Okay, that's great. We're hitting that point. We go down 1, over 2 again. So it's going to go through the point over here. And so we can connect those together. And it'll look something like this. Okay, so here's the perpendicular line, y equals -1/2 x plus 3. So you can always kind of check your work by, I know it can get lost a little bit in algebra, and there's always a way to kind of see if your answer makes sense. Right? Math should make sense in any way that you look at it. So I encourage you to make little sketches, and I know that there's a lot to remember, but the more that you do it, the easier it gets. Okay, so this is the end of our review on lines. We will be working with lines throughout the semester in different ways. So I hope that this was a good review for you. And next time we will review functions. So I'll see you then.